This video is pretty straightforward, in which we are just graphing a Principal Components Analysis graph using the Genotypic, the SNP data. And what we're first going to do is use this function which performs the Principal Component Analysis given the data matrix, which is our geno matrix, which we had before, which is essentially this one here, purely just SNP data, zeros, ones, and twos. And so we're going to run that, and that will create this object here, the PCA1. And we'll look at that PCA, and then we'll start pulling around looking at the loadings of that. So that's completed. And so just looking at the summary, we've got principal component 1, 2, 3 all the way, keeping creating those massive amounts of principal components. And I want to look at the loadings, and this will help us graph the scatter plot. So principal component 1's loadings, 2's, 3's, and so on. So we want to pull that out of the principal component function, which I believe is this one here. So there's 5 elements, and the loadings are one of them, from 1 to 292. So that's the amount of genotypes that we have. So create that, and I want to cbind so my data, my metadata essentially, so that if we look at the loadings, which are this column, we have the name of my genotypes, the entry number, the country, the maturity group, genetic background, and then the loadings that will help us graph the principal components on the scatter plot. Rename the first column to name from lowercase name, and rename it to data 4, because that's what I have it listed through in this ggplot. So I'm gonna plot this ggplot using the data 4. X is principal components 1, Y is principal components 2, and I've also added the color of the genetic background. So primarily we have the landrace PI lines, but we also have diverse and elite lines, which have clustered here together because they're all from the United States and they're all genetically similar. And so this is the ggplot function that I used, which is quite straightforward. We can change this to, I think maturity group was another option that I had in the yes. So maturity groups 1, 2, 3, and 4, and there's not a whole lot of clustering that comes out there. I believe I have country listed as well. It won't cluster, it won't show as well because there's many more countries than there are, say, maturity groups, which there's only 4. But I can change this to country, and we can look at it as well and run that. And it's not liking that because I have so many countries, which in the future I will break those down into more regions because we are running out of countries. But this is what Race calls the Japanese corner up in here. That's a lot of the Japanese lines congregate together because they are all genetically similar. Anyway, thank you very much for watching, and in future videos we'll move on and look further into these concepts.